Welcome back. In this video, I'm going to be walking you through some new types of problems that we haven't seen before, and the problems that we'll be doing in this video are actually what the last 3 or 4 videos have all been leading up to. In the last 3 or 4 videos, I've been showing you bits and pieces of things that will come to play in this video. So, in one of the last few videos, I showed you the z-score of a sample mean. That'll come into play in this video. I also showed you a rule for deciding if the sampling distribution is normal. And I told you that if a sample mean is being calculated, the sampling distribution has a normal shape, or at least roughly normal, if either the population is normal or the sample size is at least 30. That rule will also come into play in this video. So now we're basically gonna take all of the information from the last few videos and actually apply it in this video. And the problems that we're doing in this video might seem really similar to the z-score probability problems we did earlier this semester, the below, above, and between problems. And the problems that we'll be doing in this video are actually highly similar to those problems, but there are a few important differences that I'll mention now. So back in that topic, we were, well, back in that topic, in each problem that we looked at, a person was being, or an individual was being randomly selected from a population, and we wanted to know the probability of that person's or that individual's data value coming out below a certain number, above a certain number, or between two specific numbers. In this video, we're going to be focusing on situations in which a group is being selected from a population, and the mean of that sample is being calculated, the average, and we either want to know the probability of the sample mean coming out below a certain number, above a certain number, or between two specific numbers. So really, we have the same three situations, below, above, and between. The only difference is now we're focusing on a group of people being selected and the mean of that group being calculated, rather than just one individual being selected and that individual's value coming out to some number. So here's our three situations, below, above, and between. So if a random sample is being selected from a population, a random group, and the sampling distribution is normal, meaning the possible samples, it's possible to calculate the probability of the sample mean coming out below a certain number, above a certain number, or between two specific numbers. So notice how we have our same three situations, except now we're focusing on a mean of a group rather than just an individual value. That's really the only difference. So let's look at our first situation here. So a population has a mean age of 25, the standard deviation is 3.7, and the ages of the population members have a normal distribution, and a random sample of 15 is being selected from the population, 15 people, and the mean age of the sample is being calculated. So notice how it's not one person. We actually have a sample of 15. That's why so the sample size is provided to tell us it's 15 people. And you might remember that when we did these types of problems earlier this semester, we had to check if the population was normal, because the population has to be normal for it to be solvable. If it's not a normal distribution, the z-table doesn't lead you to the correct answer, and there's no method that can be used to solve the problem. But now, in this type of a problem, we actually have a new checklist we have to go by to decide if the problem can be solved, because now it's actually it's a little bit more complicated than it used to be, because now we're not just checking off if the population is normal. Now we're checking off if the sampling distribution is normal, which means, well, in this case, the possible samples of 15 that could be selected. And if the sampling distribution is normal, then we can go ahead and solve the problem. And to decide if the sampling distribution is at least roughly normal, we have to follow this checklist right here. So this checklist is actually something that I introduced in one of the last couple of videos. So when a sample mean is being calculated, the sampling distribution is at least roughly normal. The answer is yes, if either the population is normal or the sample size is at least 30. So the answer to this question is yes, if this is true or this is true, meaning they actually don't have to both check off. Just one of them has to check off. So if this one checks off, it's a yes. If this other one checks off, it's a yes. And if they both check off, it's still a yes. So really, you need one to check off or both. So that's why I use the word or and not the word and. So so we have to look at both of these and go back to this situation and see if it checks off. So let's see. Population is normal. Well, it says in this problem that the ages of the population members have a normal distribution, so that does check off. That's why I have this check right here. Now let's go right here. Sample is at least 30. Well, the sample is 15, which is under 30. So the sample is not 30 or more, so this doesn't check off. It would have to be 30 or more for this to check off. And since one of them does check off, that's all we need. So the answer to part A is yes, and that just means that the problem can be solved. Now, we can move ahead and actually find the answer. But if neither of these had checked off, if they had both been a no, then the answer to part A would have been no, it's not at least roughly normal because the checklist isn't satisfied, and that would actually be a dead end. We couldn't go on and solve the problem. So this part A is really just a checklist that has to be passed to move forward and solve the problem. And you have to have at least one check mark for it to pass and to move ahead. So we can move ahead. And let's see here. Let's move to part B. So we want to know the probability of the sample mean coming out lower than 23. So we need to, well, we'll be following basically the same steps we did earlier this semester. We're going to calculate a z-score and go to a z-table. And since it's a below question, the z-table gives us the answer. There's nothing left to do. The only difference is we have to have the right z-score formula because now we're turning a sample mean into a z-score. We're not just turning a data value like a height into a z-score. We're turning a sample mean, the mean of a group, into a z-score, and we have to have the formula that will turn a sample mean into a z-score, and that's actually this formula right here. So it's really the same z-score formula that we had earlier this semester, except it includes the square root of n right here on the bottom. And here is where we plug in our sample size of 15. And actually, earlier this semester, when we were doing z-scores, this n actually was in the formula. It was there, but since it was a sample size of 1, it didn't matter because if n is 1, this basically doesn't affect the answer. But now that n is 15, it does matter. I'm just explaining why the formula looks different now than it did before. So we have this z-score formula for a sample mean. So we take our sample mean of 23, and it goes into x bar. So x bar is sample mean. That's a symbol for sample mean. So just a data value like a height is x, but x bar is sample mean. So 23 goes right there. Just like before, the mean goes here, the mean of the population, which the problem tells us is 25. So on top, it's 23 minus 25. We have our standard deviation of the population, the sigma, which is provided, 3.7, and our n well, 15 people are being selected, sample size of 15. Now we have everything in here. Now, first we should find the square root of 15, 3.87 to two places. Then divide on the bottom, 3.7 divided by 3.87 is 0.96. Subtract on top, 23 minus 25 is negative 2. Negative 2 divided by 0.96 is negative 2.08. And we have to round this to two places to be able to use the z-table. So that's why I rounded it to two places. Now let's go to the z-table. So since it's a negative number, negative 2.08, we have to go to the negative z-table. In the z-table I gave you, there's two z-tables side by side, and the left one is for negative numbers. So we have to go to that left one. So the row is negative 2.0. The column is 8 because, well, the 8 comes at the end, right? It's negative 2.08. This 8 is just the third digit in the z-score. Then we go to where they meet up, and it's 0.2188. And since it's a below problem, the z-table gives us the answer, and we're done. It's 0.2188. And just like before, the next step is turning it into a percentage. I just want you to be able to write it out as both a decimal and a percentage. So to get the percentage, multiply by 100, and it's 21.88. And now finally, the last step will be a diagram, just like before. So now we're once again diagramming a normal distribution. But now this diagram is actually representing not the individuals in the population, but the possible samples of 15. So it's actually sampling distribution. So basically, this is all, we're selecting one possible sample of 15, and this is just representing all possible samples of 15 that could be selected. And R15 is somewhere under here. And here we have, so once again, we're going to put the number we turned into a z-score, which in this case is 23. The z-score it turned into, which is negative 2.08. The mean of the population, which was provided, 25, at the center. And let's see, and remember how the population mean always has a z-score of 0? So put that under here as a reference point, just like you did earlier this semester. Shade the area to the left, because this is the area that we're focusing on. Remember the problem said below 23? So this is what we solved for, so shade this going to the left. Well, the problem said, what's the probability of the sample mean coming out below 23? So this is the area that we're focusing on, below 23. So that's why we're shading it. And the problem, the z-table told us that there's a 0.2188 probability of the sample mean coming out somewhere in this area, below 23. So put the probability right here. And that's it for the diagram. So if it's below problem, shade to the left. If it's an above problem, shade to the right. If it's a between problem, shade between the 2 points. Here we have another situation. So a population has a mean age of 25. The standard deviation is 4.2. And the ages of the population members have a normal distribution. Now a random sample of 18 is being selected, and the mean of the 18 is being calculated. So once again, we have our checklist that we have to pass, and the problem says that the population is normal, so that checks off. Now, is the sample 30 plus or 30 or more? Well, no, it's only 18, so this doesn't check off. But remember, just one or the other has to check off, not both. So since we got one check mark, we can move ahead. The answer to part A is yes. Now in part B, we want to know the probability that the sample mean comes out higher than 27.5. So just like before, we plug in our information. The sample mean of 27.5 that we're focusing on goes into X bar. This is what we're turning into a z-score. We're turning 27.5 into a z-score. The population mean is provided, 25. Standard deviation, 4.2, that's provided. And it's a sample of 18. N is 18. This all goes here. And so yeah, the sample mean that's provided, well, I mean, the sample mean that we're focusing on is right there. The population mean, standard deviation, sample size, and they're all provided. Once again, we take the square root. So the square root of 18 comes out to 4.24. Divide the two numbers on the bottom. It's 0.99. Subtract on top, 2.5. Divide 2.5 by 0.96, and we have this answer. So it's positive 2.60, and I put the plus sign there because it's important to show if it's a positive or negative z-score, because that affects which table we're going to. And it also has to be rounded to two places to use the table. So it looks like we're going to the positive z table on the right side, and we're going to row 2.6 and column 0. So it's row 2.6, column 0, and here's the number. But it's a higher than problem, which means, just like before, we need to do 1 minus this number. So it's going to be 1 minus 0.9953. So it looks like the answer is 0.0047. And now the next step, just like before, is a percentage. We're multiplying that by 100 to get a percentage. It's 0.47%. Now we have our diagram, and the diagram is the same as before, except now we're shading to the right of our number, because the problem said, in part B, it said, what's the probability of the sample mean coming out higher than 27.5? So we're focusing on the possibilities above 27.5 to the right, which means we have to shade to the right of our number. So the shaded area is just the area that we're focusing on. And the answer is 0.47%. So what this is just saying is, in this situation, there's a 0.0047 probability of the sample mean coming out above 27.5 and ending up somewhere in this brown area right here. Now, let's look at one more situation. Now we have a population with a mean age of 25. The standard deviation is 4.5. And the population members are actually skewed. So the population isn't a normal distribution or a bell shape. And a random sample of 42 people is being selected, and the mean age of the 42 is being calculated. So let's look at our checklist. The population isn't normal, it's skewed, so this doesn't check off. But 42, that does check off, because that does meet the 30 cutoff, because it's equal to 30 or above. So check that off. And since we have one check mark, the answer is yes, and we can move forward. Now we want to know the probability that the sample mean comes out between 24 and 27. So just like in the other type of between problem we did earlier this semester, we're going to get both z-scores. We're going to turn 24 into a z-score and 27 into a z-score. The only difference is we're using our new z-score formula with the sample size. So 24 goes right there. 27 goes right there, right here. The other three numbers are the same, 25, 4.5, 4.2. They're all provided. So when you look at this formula right here and this formula down here, the only difference is this first number, 24 and 27. The other three numbers are the same. And this z-score turns out to negative 1.45. This one plus 2.90. And what we need to do now is look up both z-scores in the z-table. So the first one was negative, what was it, negative 1.45? Yeah, so this one is going to be, well, we're going to the negative z-table, and it's going to be row negative 1.4 and column 5. This one down here is going to be in the positive z-table, and row 2.9, column 0. Remember, I told you that the third digit at the end is the column digit. So here we go. This z-score leads us to 0.0735. This other z-score leads us to 0.9981. And just like before, we just subtract the bigger number by the smaller to get the answer. So it's going to be 0.9981 minus 0.0735. We take the two numbers from the table and subtract the bigger by the smaller. Yeah, 0.9246. And now we just change it to a percentage times 100. And then in part D, we make a diagram. And just like before, we have the population mean, which in this case is 25 right here. The mean always has a z-score of 0, so put 0 right there. Put the two numbers we turned into a z-score, which are 24 and 27. So 24 is out here because it's below 25. 27 is up here because it's above 25. So make sure to pay attention to whether the number is below or above the center point. And 24 turned into this number, the z-score. 27 turned into this z-score. And we're shading between the 2 points because this is the area that we're focusing on. The problem said, what's the probability of the sample mean coming out between 24 and 27? So that's the area we're focusing on, so it's shaded. And here, this is just saying that in this situation, there's a 0.9246 probability that the sample mean will come out between those two numbers, 24 and 27. So yeah, so I walked you through some examples of how to solve this type of a problem. And in the next topic, we're actually going to get into how this, or we're going to start to get into how these calculations are useful in actual real world situations. So here in this topic, well, in the examples that we're doing in this topic are really just a foundation to help you understand our next topic, which is margin of error. And in that topic, you'll actually see how these concepts are used in a real life survey situation. And you'll start to see even more of its real world application once we get to confidence intervals. So in this class, the real world usefulness of some of these concepts isn't obvious right away because I have to start with simple basic examples to teach you the foundation, and then we build up to how it's actually used. So just know that that's going to be coming later. And if you have any questions, just let me know.